We're going to be working on section 9.2 today. We're going to take the idea of the mole and we're going to combine it with the idea of a chemical equation. So moles and chemical equations both together. Combination reaction, a 2 mole to 3 mole produces 1 mole. Now, as we learned previously, the mass of reactants is same as mass of product. What we're concerned with is the number of atoms that are reacting or the number of moles. A mole-to-mole factor or mole-to-mole ratio of any two substances in the equation. So between iron and sulfur, we can say there's 2 moles of iron for every 3 moles of sulfur, or 3 moles of sulfur for every 2 moles of iron. So we can get the relationship between iron and sulfur. For iron and iron sulfide, we say 2 moles of iron to 1 mole of FeCl3, or 1 mole of FeCl3 to 2 moles of iron. Using again the coefficients, 2 for iron and 1 for FeCl3. Same goes for sulfur and FeCl3, a 3 to 1 ratio or a 1 to 3 ratio. Notice that including the formula for the substance. It makes the conversion factor a little bit longer, but having the formula in there helps see the relationship between all the different substances. So go ahead and get out your mole diagram from chapter 7, and we're going to take our mole diagram and we're going to add to the grams and moles section and label it known. So this whole row, and you can put known over here under particles too if you want, but this whole row is so here's an example problem. It says the chemical reaction of iron and sulfur. How many moles of sulfur are needed to react with 1.42 moles of iron? So we have a balanced equation, which can't do anything without a balanced equation. And we're looking at our problem. We're given here 1.42 moles of iron. That's our known. And our unknown is moles of sulfur. So we're going to get from moles of known to moles of unknown, I'm going to need to know the mole-to-mole factor or the mole ratio. On top is going to be So we would start with the number in the problem, 1.42 moles of iron. And then we're going to put in our conversion factor. We're trying to cancel moles of iron. That's our known. So that's going to go on the bottom. So the coefficient for iron was 2. So 2 moles of iron over the top is going to be 3 moles of sulfur. So moles of iron can cancel. We're going to take 1.42, multiply by 3, and then divide by 2. You have to do both on top and bottom. I put that in my calculator, and I come up with 2.13 moles of sulfur. Because these are coefficients from the balanced equation, they are exact quantities, so they do not affect the significant figures. Going back to our original number, 1.42, 3 significant figures. Our answer should have 3 significant figures as well. So, again, 3 significant figures in our original problem and 3 significant figures in our answer. So here's another example problem. Propane gas, C3H8, as a fuel used in propane camp stoves, used in soldering torches, such as the one shown down here. And some cars can actually, and buses can use propane. And also the big tank outside your house, if you have a gas furnace, is full of propane. So when we burn that propane, combustion reaction, of course, combining the propane with the oxygen to produce the carbon dioxide and water. So here we have our balanced equation. And the question becomes then to us, how many moles of carbon dioxide can be produced if I have 2.25 moles of the propane gas? So in this problem, first we would need to decide what is our known and what is our unknown. So we have 2.25 moles of C3H8 is my known. And then my unknown is moles of CO2. To get from moles of known to moles of unknown, look at your mole diagram, and we see that we want the mole ratio to go in there between moles and moles. So that's going to be my plan. I'm going to take the 2.25 moles of C3H8. That's my known. That's what I'm going to start the problem with. Then I'm going to put in my conversion factor. The unknown, which is CO2, here is my unknown. That's going to go on the top of the equation. The coefficient in the balanced equation for CO2 is 3. So I'm going to say 3 moles CO2 goes on top. And then the coefficient in front of the C3H8 is going to go on the bottom, and this coefficient is just 1. So 1 mole C3H8. Then looking at my units, moles of C3H8 can cancel. And I'm going to take 2.25 times 3, divide by 1, and I come up with 6.75 moles CO2. So that's how you do